Hello chemistry learners, welcome back to Organic ChemWords YouTube channel. Today I am back with one more organic chemistry question. We are going to discuss about a molecule called vanillin. Before we start solving the question, I would like to give some interesting and important facts about this vanillin molecule. Vanillin is an organic molecule which is extracted from vanilla beans, and it is responsible for the smell or the flavor of vanilla ice cream or vanilla chocolate, etc. Right, the sweet smell, right, the sweet flavor of vanilla ice cream is due to the vanillin molecule. Alright, we can also give the UPAC nomenclature for the molecule. What is the principal functional group? Aldehyde. What are the other two functional group we have? There is a phenol and then there is a ether, that is methoxy, and we have hydroxy. Now how to name this? The principal functional group is aldehyde, therefore this is benzaldehyde, and you can start numbering the benzene carbons like this. And we have two prefix here, hydroxy and methoxy. How are we going to arrange them? According to the alphabetical priority. Hence H comes first, right? 4 hydroxy, and what is this? Methoxy. 3 methoxy, 3 methoxy, and overall it's a benzaldehyde molecule. Trust me, this name, right, it's going to help you to answer the given question. How? I'm going to explain very soon. Now, what is the question about this 4 hydroxy 3 methoxy benzaldehyde, that is vanillin? That you are supposed to choose the right statements from the given 4 options. So let's get started. The vanillin molecule can be obtained as a major when 3,4-dihydroxybenzaldehyde is treated with 1 equivalent of NaOH and 1 equivalent of methyl bromide. Let's verify this particular statement. Alright, so first we need to decode how to convert this name to structure. So first you start from here, benzaldehyde. Start from benzaldehyde. What is benzaldehyde? Benzene with CHO. And now 3 4, if this is the ipso carbon, so 1 2 3 and 4 dihydroxy, right? It is treated with 1 equivalent of NaOH and methyl bromide. Methyl bromide is also written as MEBr, okay? Methyl bromide. Then they say that it's forming P. Let's verify that. How to do this? See, there is only one equivalence given, right? Which hydroxyl group is going to react? If the OH on the para position reacts with the sodium hydroxide, because phenols are acidic in nature, NaOH is basic in nature, it's a kind of neutralization reaction, isn't it? Reaction between an acid and a base. You're going to get a salt. What salt are we going to get? A sodium phenoxide salt, like this, like this. What about here? The OH will remain as it is, right? Why so? Because between these two, this is a phenoxide form, so that it is stabilized by resonance and also an electron withdrawing group, which is -R. Suppose the phenoxide is formed here, then it will be stabilized by the benzene ring but not by the -R group, so not so acidic as compared to this one. Therefore it prefers to form at the para position. And you have methyl bromide, simple nucleophilic substitution reaction. Our nucleophile, what is the nucleophile here? Phenoxide, right? So let's show it like this. The phenoxide will attack the methyl and bromide will leave the molecule. NaBr is a byproduct which we are not bothered, right? So this is CHO, and here OCH3 What about here? The OH is as it is. So you are doing a methylation of the hydroxyl group. There are two hydroxyl. You have to decide whether the meta hydroxy will undergo reaction or para. I told you it's para because when the para phenoxide is formed, it is stabilized by the minus R group, that is aldehyde. Hence, the methylation is happening at the para position OH group. Therefore, you are going to get this as a product. Now, let's compare it with P. The para position, we have hydroxy. Do we have hydroxy here? No, that is not possible. So, the reaction is giving isomer of the P, that is a positional isomer, but not exactly the P. So, is this a correct statement? No, A is not a correct statement. Alright, now let's analyze option B. Now, P can be obtained as one of the products when 2-methoxyphenol. So again, we have to write the structures of the molecule. First, you write down the phenol. This is phenol, right? 2-methoxy, like here, methoxy, okay? 2-methoxyphenol is treated with chloroformine aqueous KOH. Chloroformine aqueous KOH, right? So instead of thinking what will happen when chloroform reacts with this molecule, I tell you, just try to recollect where you have seen these reaction conditions. A phenol, chloroform, KOH, this should ring the bell of Reimer-Tiemann reaction. Students, remember Reimer-Tiemann, a named reaction, is a very popular reaction, and it will be given most of the time as a sequence of reactions. So remember that. What is Reimer-Tiemann reaction? It's a formylation. That means you are going to introduce an aldehyde on a phenol molecule. Okay, so you are going to introduce at para and ortho position because OH is a ortho para directing group and this enters the molecule as an electrophile, so it can go to ortho position also. But look at the statement, P can be obtained as one of the products. So I am getting para as well as ortho. It says one of the products. Yes, this is one of the products and statement B is correct statement. Remember students, usually ortho is the one which is the major product, okay, due to intramolecular hydrogen bonding, but that's not the option. It says that it's going to be one of the product, which is correct. Okay, so the statement B is correct. Okay, so far we got one right statement and we got one wrong statement. So you please keep copying these reactions so that I can move forward to the next two statements. All right, so let's read out the statement C. The positional isomer of P can be obtained when 3,4-dihydroxybenzaldehyde is treated with 1 equivalent of NaOH and 1 equivalent of methyl bromide. Students, remember this is something what we have done with respect to option A, isn't it? Positional isomer of P can be obtained. So this is statement C, right? So look at this. Same molecule, 3,4-dihydroxy, 3,4-dihydroxy, 3,4-dihydroxy benzaldehyde, when it is treated with one equivalent only. So that means what? NaOH followed by methyl bromide, like this. And I told you here the phenoxide will be formed, and what you are going to get? You are going to get O-methoxy here. But is it vanillin? No, because in order to be vanillin, the hydroxyl must be para position, but it is a positional isomer. What do you mean by positional isomer? They have the same molecular formula, but the position of the functional groups here it is being interchanged. Therefore, the statement C also holds good. Okay, so you don't have to redo this, okay, because we have already done it for A. So you can quickly choose C as the right statement. All right. Now, P can be obtained when 3,4-dihydroxybenzaldehyde, again you can write the 3,4-dihydroxybenzaldehyde, right? It is treated with 2 equivalents of NaOH and 1 equivalent of methyl bromide. This is quite interesting. When you are using 2 equivalents of NaOH, right, that means what? Both our hydroxyl groups are going to be phenoxide ions like this. Now, you treat this with methyl bromide. See, this phenoxide is busy in resonance, isn't it? Then which is available? This O minus is available. So what it does? It goes and attacks our methyl group. This is a key step here, okay? So what happened? Both form phenoxide. One is busy in resonance, okay? The other one used that opportunity to attack the methyl, right? And then acidic workup means what? You just add some acid at the end, so that what happens? You are going to neutralize the reaction. So what you are going to get here? You are going to get the vanillin molecule. So P can be obtained by the process given here. That is a true statement. Therefore, the right option is option D. So for questions like this, it is always better to write down the reactions. For example, for A and C, the reactions are exactly same, right? So that will help you to choose the right statement. You can eliminate a wrong option, okay? So this is the bonus tip for you, that you have to write down the reaction, which will help you for more than one options, right? Okay, so I hope you have understood this. If you have not, you can always ask me questions in the comment section. Thank you for watching this video. Until next time.